To answer this question, let's consider a couple of places on the surface of the Earth. So first off, let's imagine that you're standing at the North Pole. And let's think about the forces that are acting on you. So if you're at the North Pole, of course your weight will be pulling towards the center of the Earth. And since you're standing on the surface, there will be a normal force away from the center of the Earth. You're not accelerating. You might be spinning in a circle as the Earth turns, but you're not accelerating, so if we sum the forces, in this case in the y direction, then that would be normal force minus mg is equal to 0. So the normal force, the force that's measured by the scale, is going to be equal to your weight. Now let's think about what would happen if you're standing at the equator. If we draw a free body diagram now, once again, your weight is pulling you towards the center of the Earth, and there will also be a normal force. So if we sum the forces, these are the two forces we have to take into account. But now the situation is a little bit different because now your body is going in a circle that's equal to what a point on the Earth goes through as the Earth rotates. So you're traveling around the circumference of the Earth in 24 hours. So since you're going in a circle, the direction towards the center of the Earth is the direction of centripetal acceleration. So that means this is the direction of centripetal acceleration pointing to the center of the circle you're traveling in. So now when we sum the forces, mg is towards the center of that circle. The normal force is pointing away from the center of the circle. And so the difference between these two forces is now equal to your mass times your centripetal acceleration, or mass times speed squared over r, where the speed is your speed going around the circle. So now since you are accelerating, because you are traveling in a circle, there is this acceleration to contend with. So now if we solve for the normal force, pull the n to the other side of the equation, the normal force is going to be equal to mg minus mv squared over r. So the normal force will now be a little bit less than your weight. So the scale will show that you weigh less at the equator than you do at the North Pole. It's not by a huge amount, but it will be a little bit less, because now as you're going around the circle as the Earth rotates, it's as if the Earth is throwing you outward a little bit. So near the equator is where you would weigh the least. So you would weigh the least at the Galapagos Islands near the equator.